Hi friends, one of the most interesting Arduino projects I have done is the OLed Meter. It's based on the current sensor INA219 and a small OLED display. In this video, I will show you how I developed this circuit to be a nice and small product which can be sold or used in your lab. First, let us check the circuit in detail. The current sensor uses the INA219 chip, which calculates the current by measuring the voltage across a small resistor called shunt resistor, and its value here is 0.1 ohm. After using the simple Ohm's law, it's easy to get the current value. Afterwards, the chip sends the value via I2C bus, or as I like to name it as I2C. This protocol allows any microcontroller to communicate with many other peripherals just by using two lines, which are SDA and SCL lines. The project also contains an OLED display with size of 0.91 inch. It is a nice decent display which has a clear show, and its small size is very suitable for portable devices. The good point here is that it uses the same I2C protocol via its SDA and SCL lines. The last part is the Arduino, where here I have chosen Arduino Nano, which is small and I don't need more inputs and outputs. You can use Arduino Pro Mini, but you should have the external programmer to install the sketch. To increase the circuit capability, I have added the voltage measurement as well, by using the simple voltage divider circuit and reading the value by Arduino. To make the project portable, I added a small boost converter circuit which boosts the voltage from about 1 volt and outputs a regulated 5 volt. Therefore, I can use a 3.7 small lithium battery to be the power source. Here we are using the EASYEDA website for our design. It offers a nice and free platform for drawing the schematic and producing the PCB design. The battery inputs are connected to the boost converter circuit via a slide switch. The boost converter output will supply the other circuits on their VCC and ground lines. The current sensor and the OLED data lines are connected together to Arduino pins A4 and A5, which are also the SDA and SCL lines. The voltage divider output is connected to pin A0 in the Arduino. After finishing the schematic, we make sure that all parts have their own packages, which are the footprint on the PCB. If you didn't find one, you can easily create it by choosing File, New, PCB Lib, and after drawing the real size package, you can save it in your library. Now it's time to design the PCB by pressing Convert Project to PCB. From this point, it all depends on the user's experience. Here we have some constraints. I want the circuit to be as small as possible, so I have chosen the dimension to be 5 cm length and 3 cm width, but you can choose whatever you want. As we have here 4 circuits, which are the Arduino, the OLED display, the voltage and current sensors, and the boost converter circuit, it's difficult to fit all these on the top layer within the chosen dimensions. Thus, I left the Arduino and the OLED on the top layer and moved the current sensors, voltage divider resistors, and the boost converter to the bottom layer. At this point, you should be very careful in arranging your components and organizing the boards. Try to avoid any wrong contacts between the top and bottom layers components, and keep good gaps between the pads to ease soldering it and to not be shocked if it was crowded. At the end, I have added holes in each corner, which is used to fix the circuit by screws if needed. To draw the cover tracks, it's easy to use the auto router feature, which automatically generates the tracks network. It's easy to make the tracks not less than 10 mil, and here I choose 15 mil, and the gaps between them it's about 10 mil at least. After running it and waiting for a few seconds, we can see our design ready. You can have a final check on the tracks, distances, and widths. Also, you can see top and bottom views and then print the design to make sure again that all components have their right sizes. Now it's time to send it for fabrication by pressing the fabrication output button. And here we see your board data, and after choosing the quantity and the delivery options, you can make the order and wait. And here we got our boards. EASYEDA is a professional company that offers high quality fabrication service, and you don't need more than this for this kind of projects. All paths are well done and the writing are very clear. Before soldering, we should make sure that all components fit well as expected, and to prevent any undesired contacts between the boards, I used an adhesive insulator. And here comes a new challenge: how we solder all these overlapped boards. If we solder the Arduino board first, it is difficult to solder the current sensor header. So I decided to solder the Arduino pin header first without the Arduino board and soldering all components underneath it like the voltage divider resistors, the current sensors, and boost converter headers. You might notice some floating pads in the boost converter and the current sensor. And here I have added some additional pads in the main board to solder some small wires to these pads. Afterwards, I have soldered the switch and the battery input header, and finally I programmed the Arduino board and soldered it to its header. You can find the design and the code in the video description. The code simply has two parts. The first part initializes the board to communicate with the OLED display using the U8G2 library and with the current sensor by the Adafruit INA215 library, and both use wire library for I2C protocol. The second part is to read the current and voltage values and then show the readings on the display every 200 milliseconds. Now it's time for testing. I connected the battery and turned the switch on. Unfortunately, the display didn't show anything and I realized that I flipped the OLED header from right to left. I fixed this mistake manually by taking off the OLED pins and using solid wires to change the pin arrangement, but all these changes definitely will be updated for any future versions. After doing the test again, all worked pretty well and as expected, and the display shows some values. After connecting an external voltage source and a load, it's easy to see the readings of the voltage and current. Although the readings have some error which is within 5%, I am very happy with the results so far. I hope that I have a 3D printer to make a package for it, but maybe in the future. I hope you like the video and the design process we showed. If so, please like, share and subscribe, and tell us in the comments below about your project idea which might be our next project video. See you next time.